Hey guys, I hope everybody's well. We're working on time series. I'm reposting a video here, so you may have seen a slightly different version of this, which had a little bit of a mistake in it. So I'm going to try to fix that mistake in this one. Let's see, where are we? We're working on time series, and we're doing a practice problem where we're going to be deseasonalizing some data, and then we're going to be estimating a trend, and then we're going to be seasonalizing forecasts. So I'll read the question first, and then we'll work our way through it. It's from Chapter 18 in the Anderson book, 11th edition. Hudson Marine has been an authorized dealer of CND marine radios for the past 7 years. Suppose the quarterly sales values for the 7 years of historical data are those given on the Data tab. And I'll show you the Data tab quick here. You can see that we have years 1, 2, 3, 4, 5, 6, 7. We have quarters and we have sales. Okay, now the problem is going to ask us to do a bunch of stuff. I'll read it all first, then we'll go through it. A. Compute the centered moving average values for this time series. B. Construct the time series plot that also shows the centered moving average and the original time series in the same graph. Discuss the differences between the original time series plot and the centered moving average time series. C. Compute the seasonal indexes for the 4 quarters. I'm going to assume that means adjusted. D. When does Hudson Marine experience the largest seasonal effect? And does it seem reasonable? Explain. E. Deseasonalize the data and use the deseasonalized time series to identify the trend. F. Use the results from the deseasonalized series to develop a quarterly forecast for next year based on trend. And then G. Use the seasonal indexes to adjust the forecasts, the trend forecast developed in part F to account for the effect of season. Okay, we'll take these one at a time. First, we're going to compute the centered moving average values for the time series. Let's see. And if you recall, well, we're doing centered moving average values, so we're smoothing. But with quarterly data, we have a period of 4. Right? Periodic, the periodic effect has a period of 4. Now this is a little bit problematic because to do a centered moving average, well, let's look at one. Well, let's say we had y1 plus y2 plus y3 plus y4 over 4. Well, this is a centered moving average, but it's a centered moving average for period 2.5, which doesn't actually help us much. We don't have a column or a row for 2.5. Alternatively, if we had a y2, the next one, y3 plus y4 plus y5 all over 4, well, that's the smooth observation for period 3.5. Now what we can do is we can take the average of these two, S2.5 and S3.5, to get S3. And that's what we're going to do. And what this turns into is y1 over 8 plus y2 plus y3 plus y4 over 4 plus y5 over 8. And I have a video where I show you how to calculate centered moving averages where I walk through this, but here's a particular application. So that's the formula we're going to use. And we're going to start with that third one because, as you can see, if we went one earlier, we'd have to start at y0. So let's do that. We'll use that formula here. Okay, so, pardon me. The centered moving average here, let me clean this up a wee bit. Let's see. I'm always going to want these to be bold. I'm always going to want them to be wrapped and vertically centered and horizontally centered. And here we go. Here we're going to have our centered moving average. And this first one here is going to be y1 divided by 8 plus y2 plus y3 plus y4 divided by 4 plus y5 divided by 8. Easy enough. Okay, so that's my centered moving average. And you can see that it's not the same as just an average of all of these. It's a little bit different because what we've done is we've weighted the first period and the fifth period at half, and that has an effect. It essentially means we're only counting 1 year's worth of data. Pardon me, I have a bit of a cough. Now, the centered moving average formula is going to be the same throughout. So all we have to do once we've done it once, thanks to the fact that we're doing this on a computer, is to copy that formula and paste it. And if you've been following along, if you're getting comfortable with Excel, then you'll notice these are all relative references. No problem. You can copy and paste it. It shifts everything down. But it's easier. Let me zoom out a little bit. It's going to be easier to just select all of these and fill down. Control D does that. All the way down, you see, this works. And every time it's centered, you can see this one is trying from these 5. Until we get to the bottom, then we have a problem. This last period the centered moving average is pulling some zeros. This period we still pull a 0. So now we have centered moving average for all the, we lose 4 points because it's a 4-period moving average, but other than that we're fine. So we have the centered moving average all the way through. Just looking at this, we see there appears to be some kind of trend, right? This is steadily growing. The centered moving average is growing. And that's kind of what we want to look at in Part B. Part B is asking us to construct a time series plot that also shows the centered moving average and the original time series. So let's take a look. In order to do this, we're going to need to create a period variable, which is just 1, the first period, and you add 1 every time. So it's going to be this plus 1. So period 1, period 2, period 3, and so on and so forth until you get to period 28 in the last period. Okay, now to make this to create a time series plot, we need to select all the period stuff as well as these 2 things that we want to include in our chart. Go to Insert, Scatter, and then you want this scatter with straight lines. And as you can see, here we go. This is what it looks like. I'm going to move it to a separate sheet. I'll call this original and CMA. And you can see what we have. What do we see that's different? Well, let's label our axes first of all. Layout, axis titles, primary and vertical axis title. This is going to be sales. I think that's what it was, right? Is that the quarterly sales values? So this is the sales value. And then the horizontal axis is going to be period, right? So we have, it's in quarters as well. So I'll just put period, quarters. So the first quarter starts over here and it goes all the way up to quarter 28. What do we see here? Well, clearly we're missing some data in our CMA. We lose stuff on the edge with the center moving average. But our sales numbers have what looks like a seasonal trend, and this centered moving average manages to mostly get rid of that seasonal trend, right? We're taking the centered moving average really is giving us an annual average for every, an annual average centered around each quarter as we go along, which gets rid of those seasonal effects. You see that they were doing a little bit above trend there, and then back a little below trend in the front end and the back end. So that's part B. We've constructed a time series plot and discussed it a little bit. They're both going up, and that's worth noting. That's why we're going to take that into account. We also have some seasonal stuff going on. Part C, compute the seasonal indexes for the 4 quarters. Okay, this takes a little doing. Nothing we can't handle, though, of course. So, in order to do this, the first thing we have to do is we have to take the ratio of sales to our CMA, which is to say we have an original observation. That's this column D here. This is all of our original observations. And then we have what actually happened, or then this is what actually happened, I'm sorry. Then we have the annual average surrounding that. And what we're doing now is we're basically saying for each quarter that we have data for, how did the sales for that quarter compare to the annual average for the year surrounding that? If it did well, then we're going to have a high number. What we do here is we go back to the problem, and I'll show you the formula we're going to use. We're going to calculate a ratio that looks like this. Let's pick a slightly different color. There we go. So the ratio for period t is going to be our actual observed value for period t divided by our smoothed center moving average observation. And if RT is greater than 1, that means that, well, that was a boom quarter. And if RT is less than 1, that means that was a bust quarter. And what we're doing is we're just trying to get a measure of, how sales relates to compared to what you would expect if they were just, following that red line, the average, how sales did in each period. We can only calculate these for the periods in which we have a centered moving average. But as you can see, 10 is greater than 9.25. Copy and paste this down here. Oh, the 4th quarter not so well. It only did 39% as well, essentially, as what you would expect for the average of the year. And copy this all the way down. And you can see that, in general, the 3rd quarter is doing okay, a little higher than 1. 1.08, 1.15, 1.18. 1.09. The fourth quarter is terrible, 0.39, 0.48, 0.59, 0.75, 0.77. In general, that's what we're trying to capture with this, right? We're trying to figure out, well, relative to what you would expect for the year, how did this particular quarter do? And so that's what we've accounted for here. Now, to finish getting the indexes, what we're going to do now is we're going to calculate the unadjusted seasonal index. This unadjusted seasonal index is the quarterly average of ratios, right? So what we do here is we can take the average of, well, this is a third quarter, and where's the next third quarter? Right here's a third quarter, right here's a third quarter, here's a third quarter, here's a third quarter, and here's a third quarter, and that should be all of them. And this is the average sort of third quarter effect. On average, the third quarter did 11% better. Okay, so that's the unadjusted seasonal index for the third quarter. Now, because of the way we've constructed this, if we paste this, if we copy and paste it, it shifts them all down. So this is going to be the average for the fourth quarter. This is the average for the first quarter, and second quarter. Now, clearly, we could have moved these around, but I like to start at the top so that you can copy and paste it like that. Now, this unadjusted seasonal index then gives us kind of the average percentages that you would expect to see. I apologize for that siren if you can hear it. Gives the average percentages that have happened in our data set, right, over this 7 years. The problem is if we were to use these, it might cause us trouble. Why? Well, the average one of these is, if you look down here, the average of our seasonal indexes is 0.99. It means that if we regularly multiply our data by 0.99 later, we will be multiplying stuff by this later, then we'd be reducing our projection by 1% on average. We don't want to do that. So what we do is we adjust it so that they average out to be 1. This is pretty straightforward to do. You just divide each one by the average of the 4. And it turns out that if you take any group of numbers and divide each of them by the average of the whole, then it adjusts it so that the average of the 4 numbers, or the set of numbers, is 1. Down here you see the average of these is 1. That's exactly what we want. Why does that work? Well, I leave that as an exercise to you to show why that works. But it does work, and what we want to do is we want the average index to be 1, just like it is right there. That way, when we're multiplying stuff by it, we're not adjusting our data accidentally by some inflator or deflator. That's especially important when you get to 12-period indexes or seasons, when you're looking at monthly data. Okay, so those are our adjusted seasonal indexes. I believe that's what the question was asking us for, right? Compute the seasonal indexes for the 4 quarters. So that's what we did. It looks like we have about a 12% boost to third period, 36% boost to second period. We have about a 28% decline for fourth period and a 10% decline for first quarter. So that's what those indexes are telling us. They're helping us to see that. When does Hudson Marine experience the largest seasonal effect? Does this result seem reasonable? Explain. So when is it largest? Well, this looks like the biggest one is the winter season. It drops by 38%. It also booms in the second quarter, and that seems reasonable. Remember, these people are selling boat radios, right? In the wintertime, probably not a lot of people buying new boat radios. In the summertime, springtime, right? The second quarter. What's that? That's April, May, June. Yeah, that's when people are really getting back in their boats and getting on the water. So that makes sense that we would see this kind of a seasonal impact. Okay, so that's part D. Talk about that. Part E, deseasonalize the data. Use the deseasonalize time series to identify the trend. Okay, now to deseasonalize the data, what we're trying to do, I'll draw it out for you. If you recall from the notes video, we talked about using what's called a multiplicative decomposition model. And this is what a multiplicative decomposition model looks like. The assumption here in this model is that the data generating process, wherever this stuff comes from, looks like this. The outcome for any given period, the actual observed outcome, is the result of some underlying trend times some percentage seasonal effect, right? That's kind of what we were trying to get at with our indexes. times some irregular effect. We've tried to eliminate some of that irregular effect through the taking center and moving averages. We're going to continue to do that. Well, now to deseasonalize this data, what we're going to do to try to isolate the trend is we're going to divide both sides by season, by the seasonal effect. And we'll call this y squiggle t, I suppose. Now we're just getting rid of the seasonal effect on the right side, and this is then the deseasonalized series. So to get this, what we have to do is we have to divide both sides, or divide our observation, you can see, by the seasonal effect. So when we constructed those seasonal indexes, that's essentially what the season t is. So our deseasonalized series then comes from, actually let me insert this here. We're going to have to use these all the time. So I'm just going to copy these over. You can see that all I'm doing is I'm just copying these four numbers over and over and over again. They're just repeating over and over again. There's nothing new that I'm doing here. I just want to use these later. So in order to adjust for the seasonal impact, we take each original observation, which is column D, and we divide it by its seasonal index. And this gives us a deseasonalized series. Effectively, what the series would look like if it didn't have this seasonal impact. So in the case of quarters 2 or 3, if it's a second or third quarter, we're going to be reducing the number, dividing it by something greater than 1. In the cases of quarters 1 and 4, we're going to be increasing the number. Here you can see that we went from 4 actual sales to 6.44 deseasonalized, and here we went from 15 down to 11 because we're adjusting for that seasonal impact. By deseasonalizing the series, we're basically trying to get away from some of that. We're trying to get out the seasonal stuff that's going on, and we can look at what this looks like. This isn't technically part of the question. This question isn't part of the assignment, but we can take a look at what the deseasonalized series looks like if we make another chart. So let's take a look at what this does to our data. Insert, scatter, zigzags again. I'm going to move this to a new sheet. Original and deseasonalized. And here you can see what this does, right? We have the original sales, that's the blue stuff. And then we have our deseasonalized series. And this deseasonalized series, it tries to get out the seasonalized stuff that's going on. So that what you then see is you see performance against what we would expect relative to average performances for seasons. And so, although these dips go down, they don't go down by as much as we would expect. So the deseasonalization means that they're actually boosts up. So that's basically what's going on. Okay, now that we have the deseasonalized series, this allows us to estimate our trend. To estimate our trend, we're going to have to take advantage of a trend model. We're going to use a very simple trend model. The trend model we're using is this one, basically, that the deseasonalized series is a function of an intercept term and slope term times the period, t or period, whatever you want to call it. T is usually what's commonly used, plus some error term. So we'll use that very simple trend. To estimate this, we take the deseasonalized series as our y variable, as our left-hand side variable. And we just throw in, as you can see, just one right-hand side variable, just trend. And when we estimate this, we'll get an estimated trend equation that looks like this. T, the trend for period t is equal to b0 plus b1 times t. And we'll just use regression tools. If you haven't done so already, you're going to need the data analysis tool pack installed to do this. Once you've installed that, and I have a video that shows you how, click on data, go to data analysis, go down to regression, and click OK. Now our y's are going to be our deseasonalized series. That's easy enough. Our inputs, our x's, are just going to be our period numbers. So we're really just regressing it just on a number that goes up by 1 every time. We do have labels included. I included period and I included the first one right there and one right there. And we're going to call this DCs equals trend. That'll just give us a new worksheet. That's all the stuff we need because we're really just interested in point estimates. We don't need anything about residuals for now. We'll click OK, and this is the output. Now the numbers that are important here are these two right here. This essentially says that our intercept is at 6.33. That's what happens when period equals 0. And then every period it goes up by 1.05 is what this tells us. We're going to take advantage of these to calculate our trend. And that's what we're going to be doing next. Trend projection, or trend forecast is another name for this. I prefer trend projection because I like to use forecasts for once I've seasonalized it again. Okay, so now to project the trend. Okay, so what we've essentially done is we've taken our deseasonalized series. We've used regression to try to get rid of some more of that irregular stuff. This means that now we have just a straight line. This straight line looks like this. It's going to be our intercept, which is DCs equals trend B17. I'll press F4 to make it an absolute reference, plus, and then we're going to have this coefficient times our period. And if we copy and paste this, we should see that B17 and B18, these up here, right, this and this don't change, because this is B0, and this is B1, and this is the T part. The T part does change as we scroll down. We want it to change as we go along. So right here, it's referring to 1, and then here it refers to 2, 3, 4, over and over and over again. We can copy and paste this all the way down. And now, if we want, we can add the trend to, let's see, to this chart, and you can see what it looks like. And you can see that this trend, except for that weird, it doesn't exist there because I'm pretty sure that's the label, which I didn't include. But it's just this straight line. And what it actually is, if you look at this and you insert a trend line to our deseasonalized series, it should be the same as that. I'm not sure why it's not exactly identical. The slope certainly is identical. Let's see if we've done something incorrect. A trend line. Maybe that's because I'd selected. No, it's up higher. Hold on one sec. 1.0547 plus 6.33. I bet it's because, yes, it's just because I've shifted. When I fix this, it should be K2. There, now it's perfectly aligned. That's what it should look like. I just had an extra data point there. You can see that the trend line that I installed with this linear deseasonalized series, this linear thing, it's a perfect fit. It's just the line that shows up. That's what the green one did. It just estimated that best fit. So that's what we did. We just estimated that line of best fit on our deseasonalized series, and now we're just citing what those actual calculated numbers are for our trend projection. We're almost done. That was what E was asking us to do. We used the deseasonalized time series to identify the trend. Okay, part F is asking us to develop a quarterly forecast. Actually, no, that's E and F. Part E, identify the trend, is this right here. We've identified it. And in fact, I should write the trend equation so that you guys can see it totally explicitly. The trend equation, the trend for period T is equal to 6.331502 plus 1.055 times period. And that's what our trend equation is. That's part E. And then part F is this set of numbers right here where we've identified this. Does it ask us to do forecasts for next year? It does ask us to do forecasts for next year. Okay, so now we are into the realm of the future. They didn't ask us to do this yet, but we can. So next year, we're going to have periods 29, 30, 31, and 32. And we're going to have 4 quarters again. We don't have any sales or centered moving average. Actually, let me freeze panes here. We'll keep that by itself. But what we can do now is we can copy and paste this trend projection down And this just extends the trend. Basically what we're doing now is we're taking this green line and we're just saying, well, what if it continued up to the right? What values would it kick out? And that's what we've done here with this by adding these 4 numbers. And so it's easy. It's very easy to complete the question part F, developing a quarterly forecast based next year on trend, because it's just the same formula for 4 more periods. So that part is done. Okay, now last but not least, we're going to do some cool stuff by taking the seasonal indexes to adjust the forecasts in part F to account for the effect of season. So these are our seasonalized forecasts. Let me make this wider so it fits nicely. In order to seasonalize our forecasts now, going back to our model, what we did was we took out the trend, we took out the season here, we estimated the trend, and now to get our season back in, we take what we calculated, our trend right here, and we get our forecast. Forecast is going to be our trend for T, which we isolated, right? That's this, times our season T. So we're putting that back in. We've tried to isolate and eliminate the irregular portion, just get the trend, and now we're putting the season back into that. So let's do it. In order to seasonalize these, we need to take all of our trends and multiply them by the adjusted seasonal index. You can copy that and paste it all the way down. And now we have seasonalized forecasts. What do these numbers look like? Well, let's see. Let's take some got period, observed sales, the deseasonalized series, the trend projection, and the seasonalized forecasts. That's a bunch of stuff. Let's see if it looks good at all on one of these. Move chart to big ol' mess. There we go. We don't actually want period to be on our chart. But what do we see here? Okay. Well, we see that we have our original sales. This is the red line that goes through. The green is our deseasonalized series. I can delete that because we used that to get the trend. The red is the trend projection, right? So we estimated the trend up through here. We extended it out to the future. And you can see that, what else did we do? Well, it looks like we then took, that's exactly what we did, right? We modified it by adjusting it for seasons. This trend, in fact, just gets multiplied by the seasons to get the light blue line here. So we take this trend and we just multiply it by the seasonal index. Is this a good projection? Well, it looks like we have failed to account for the error exactly correctly, right? Or failed perhaps to account for, perhaps failed to account for the error, perhaps failed to account for the seasons exactly correctly, because it looks like when we have actual sales, the red line zigzags a little bit more than our seasonalized forecast at the beginning, and a little bit less than our seasonalized forecast at the end. But still, considering the data we have, this is going to be the seasonalized forecast here is going to be a pretty good projection. We might need to adjust it. Maybe there's a different model, a slightly better model. But this is one way to do it, right? We've taken our deseasonalized, or we've taken our data, we've calculated seasonal influences, we've estimated a trend by deseasonalizing the data and running a regression. We use that regression results, the estimated equation, to project the trend, and then we use our seasonal indexes to come up with seasonalized forecasts. So that's how you take data and do all this cool stuff to it. That's pretty much the whole shebang. If you have any questions, please do shoot me an email at jjdelaney@ualr.edu or leave me a comment on the video page, and I will be in touch soon. Thanks, guys, and I'll talk to you soon. Bye.